Okay, ENS, Ethereum Name Service. So what that allows us to do is allows us to have our normal Ethereum network account, a long address, and we can now turn it into something short, like what I've done for my address, ripto.eth. Actually, if you go to the Ethereum Name Service, they have a Medium page, and you can go and they have an article about all the people who have this address. There's me. You can see even the tag's got one, and the number of people who actually are doing this with their accounts and showing it. It started as a meme, but it's really been great in terms of the community of spreading awareness for this great service. So instead of dealing with those long addresses, now you can deal with a short address. So if you go to, let me just show you. So if you go to their naming service website, apps.ens.domains, you could search for the name you want. I'll show you mine. And for a few bucks, if your name is shorter than or longer than 3 or 4 characters, you can get yours if it's available. And you just go here and you sign a couple transactions, pay the fee for the address. Then you can use the public resolver to allow you to resolve the Ethereum address into the named address that you want. You add your address in, and then you just create a reverse record to point the name that you have to the address you want to use with that. And then you can create subdomains and a whole bunch of other things. I'm just go to the documentation. I'll just show you how it works. So they have a contract. You become the owner address for that domain and the contract. There's a bunch of subdomains, and then there's a bunch of resolvers. So when the resolver, we're using the public resolver, will then, when it gets called, turn the address that you registered into the actual address on the Ethereum network, or vice versa. Okay, so the behavior we want in our app essentially is, so we're used to seeing addresses. Open a regular account. So we're used to seeing addresses like this, right? Long addresses. So, but if the user actually has an address registered with ENS, we want to show that address. So here we translated that into my address that's been going through ENS. And I have another one that's for this project. You can see here, it'll translate it. And then if the user doesn't have an ENS address yet, we'll just display that as is. Okay, so it's very easy to do. So if you remember, we were getting a provider in Web3. So if you haven't seen some of the videos earlier in the series, you may want to watch those just so you can catch up with where we're at here. But for those of you who are caught up, so we're getting this injected provider from MetaMask right now. And then we set that into our state. And then this hook runs when the injected provider changes. So it will then go and set the address and the provider into our state. And then when that changes, whenever the address changes, this hook will run. So this hook will get the balance for that address. It will then convert the way balance into ETH. And also it's calling a lookup address on the regular Ethereum address that we have, and then providing back a reverse address. So then we go, and when we display it, let me show the display. Where are we displaying? So when we display it, we say, do you have an ENS address and state? If you do, we show that. If you don't, we show a regular address. So that's it. So you just have to go and call this. And actually with Ethers, you don't even need to do that step. So with Ethers, it's possible to just call this, and if it doesn't have an ENS address, it'll just return you back a regular address. So let me just show you in the documentation a couple of things. Okay, so yeah, so if you install an ENS library or compatible library, so Web3 actually won't allow you to do the reverse call, but Ethers, which you're using, we just do lookup address on either, and we'll get it back. And then here with ENS, we are calling .reverse. So ENS, the team has an Ethereum ENS library where you can call .reverse, and then that will provide you the name back. Web3, so if you're using Web3, you'll probably have to use another library. So any of these other ones should work for you. I suggest Ethers just because that's what we're using. You can follow along. So that's it. Super quick, awesome service. So quickly, one last thing to show you. I mean, this is a big deal for the community, I think. So it's really made dealing with addresses a whole lot easier. It really works, and a lot of systems are supporting it. So MetaMask supports it, as do some exchanges, some other tools. So if you were to go and send something, some Ether to someone or any token, you can now resolve with ENS. So if I did like one of my accounts, it actually resolves, which is really cool. And you can put anyone that actually resolves. It's like I said, Vitalik some money. So I mean, it's great. I mean, it's so much more usable than the long addresses, and the fact that it's running now in production, it works. I think that's why you're seeing the proliferation of addresses and the adoption of this great service. So let's see. So next video, we're going to look at using Loom with React hooks, and then setting the state on that, and then plugging that into Ethers. So we'll switch out of Web3. And then the video after that, we're going to onboard users. So we're going to use something called Portis, which allows your users to create just a username and password to manage their keys. And we'll also provide the users an option to MetaMask just to make it easier on board. And we'll cover some other things like meta transaction-based onboarding as an option. So using something like universal logins as well to be more forward-looking.